Hello guys, and welcome to a new video about exciting math theory brought to you by the MZH guys. Today we're gonna see how we can solve first degree equations with one unknown. So let me start first with the general framework. We are trying to solve an equation of the form ax plus b is equal to 0. And obviously the unknown here we're looking for is x, and a and b are just two numbers. They can be the numbers that you know, the natural numbers like 0, 1, 2, or -1, -2, -3, or they can be square root of 2, square root of 3, but they are known parameters. And that's what I write here. So x, a, and b are real numbers. And don't be scared by this name real numbers. If you're not familiar with that, we're gonna have plenty of opportunity in next videos where we will discuss what a real number is. But for now, let's just assume that a, x, and b are numbers that you're familiar with, and we're trying to extract what x is. So let's first call S the set of solutions to E, and E is referring to this equation, so we don't have to write it all the time. My point here is that I want to derive the solution of this, but at the same time prove it to you guys. So let's start. So we'll say that E is equivalent to ax plus b. So up to this point I haven't done anything, but now I'm gonna try to balance the right and left hand side by adding minus b to each side. So I'll write it here so that it is much clearer to you. 0 minus b. So what this allows me to do is actually get rid of b from the left hand side, as b minus b is equal to 0, and 0 minus b is equal to minus b. So my equation now is equivalent to ax is equal to minus b. And the intuition here is to go ahead and try to divide by a. But we gotta have to be careful here, as you all know, that we can just go and divide by the number unless we are sure that this number is different of 0. That's why we'll have a discussion from this point on. So we'll discuss the case, the majority of the cases where the coefficient that is multiplied by x, in this case a, is not 0. So if we make that assumption, now we can say that our equation E becomes x times a, and then we're gonna do the same thing. Now we can divide by a, and we're gonna do it to this side as well. And we know that a over a is 1. And therefore our equation becomes x is equal to minus b over a. So we started with our equation in a general form, ax plus b equal to 0, and we found that the solution of this equation is x is equal to minus b over a, and therefore the set of solutions of this equation in the case of a different of 0 is actually equal to the set with one element which is equal to minus b over a. And this will be our first solution in this case. So now we can go and see what other cases there are. Obviously the other case is a equal to 0. So what happens in that case? It could be confusing to some of you that, well, hold on a second. If a is equal to 0, isn't it 0 times x is equal to 0? So we don't have any more x to solve for. Well, we can actually handle that situation if we analyze carefully what's happening there. So if you see here, let's start here. So e, let's write what's happening. So e is equal to 0 times x is equal to minus b. So this is actually equivalent to 0 is equal to b. In this case, we are trying to find all the x's that verify 0 times x is equal to minus b. And you'll notice that we will have to have two discussions here. Either, so subcase, if b is equal to 0, you'll notice that e will be equivalent to 0 times x is equal to 0. So what are the numbers that verify this equation? You'll notice that all numbers actually verify this equation. 1 times 0 is 0, 3 times 0 is 0, any number actually times 0 is 0. So in this case, we can say that all numbers are solutions to this equation. And because we are targeting real numbers, we can say that the set of solutions is actually the set of all real numbers. And this is the solution in the case of a equal to 0 and b is equal to 0. Now let's see the subcase where b is different of 0. In that case, we will have e is equivalent to 0 times x is equal to minus b, but minus b is different of 0, which is a contradiction because 0 times x has to be 0. So in that case, there is no real number that we multiply by 0 and gives us a non-zero number. So in that case, there is no number that actually satisfies this equation. There's no x that satisfies this equation. And therefore, the set of solutions to this equation is actually the empty set. Again, if you're not familiar with these notations of sets, we're gonna have plenty of opportunities later to discuss the set theory and all matters related to that. So if we summarize the results that we found here, you can see that this equation ax plus b equal to 0 has three solutions based on what a and b were talking about. The first one is when a is different of 0, the set of solutions is minus b over a, regardless of the value of b. But when we get into the case of a equal to 0, then now we have to see what b is. If b is 0, then all numbers are solutions, and if b is different of 0, then there is no solution to the equation. I want to end the video by quickly illustrating what I'm talking about here by giving examples of the three cases that we discussed. So first example is a very easy one, which is 2x plus 1 is equal to 0. In this case, we can clearly see that this is A, this is B. So if we know the rule, we can either write it immediately and say because A is different of 0, then our set of solutions will have one element, which is minus b, which is minus 1 over a, and that's it. Or you can go and do the steps that I described in the beginning of the video on how to derive that x is equal to minus 1 over 2. And by saying so, I mean you can subtract 1 from both sides, and then you get 2x is equal to minus 1. And then from there, you can divide by 2, and then you get x is equal to minus 1/2. Second example is, imagine that we have an equation 2x plus 3 is equal to 2x. So this involves more work than the first example, because we need to rearrange the x terms so that we get a general equation form of ax plus b equal to 0. So what we do is, so if we name this E, we're gonna say that E is equivalent to 2x minus 2x plus 3 is equal to 2x minus 2x. So what I did is I just added minus 2x from both sides. And as you can see, this right hand side is 0. So I can write it right away. And we leave the 3. And this is of the general form, as you can see, 0 times x plus 3 is equal to 0. So we go back to our second case, where now a is equal to 0 and b is equal to 3. So what did we see before? That if we have a is equal to 0, we need to see what b is. Is it non-zero or is it 0? In this case, b is equal to 3. And from our discussion, we saw that the set of solutions is actually the empty set. The third example is, let's make it easy. Let's say 4x plus 1 is equal to 4x plus 1. And if we name this E, you can clearly work it out and find that E is equivalent to 0 times x plus 0 is equal to 0. In this case, A and B are both equal to 0. And from there, as we saw before, that all numbers satisfy this equation, and therefore the solution, set of solutions is all the real numbers. Thank you for watching this video. If you learned something or got something from it, please like the video, share your comments with us, and don't forget to subscribe to our channel. And see you in our next video.